Okay. Awesome. So the number that is in the little square root area is called the index. It's called the root. And if it's a 2, we don't write it. But if it were 3, we would write it. If it were 4, we would write it a 5. But in general, just when it's empty, just a square root is a 2, right? We call this the radicand. This is the radical symbol right here, right? If there is no index, assume that it is a 2. All right, so there's a couple of things that you guys need to know that are extremely important. These are called perfect squares. PS, perfect squares. Ready? 1, 4, 9, 16, 25, 36. I mean, I'll go to the rest, 49, 64, 81, 100. So those are perfect squares, right? And those need to be memorized by you. Cubed roots. Perfect cube roots. Ready? 1, 8, 27, 64, 125, 216, 343. I mean, I could go longer, but I'm good, right? And you know how this is like 8 equals 2 to the third. 27 is 3 cubed. 64 is 4 cubed. 5 cubed, etc., etc. So you should know those. You don't need to know all of them, but you need to be able to do in your head, what's 4 times 4 times 4? So those are my cubed roots. Fourth roots. Ready? 1, 16, 81, 256, 625. Okay. So I think those are a good reference to have on the side of your paper. Okay. Let's go to notes. Find the real cube roots of 125. Okay, well, what are the 125? What would you say? Volunteer. What times what makes 125? Naomi.
5.
5. Okay, so perfect. Now I'm going to say number 2. Cube root of 27. Katie.
3.
3. Easy. 3 times 3 times 3 is 27. Okay, so it's kind of like going backward and frontward. 3 cubed is 27. The cube root of 3 is 3. Did you guys know that if I did something like the cubed root of 5 to the third, what is that? What happens here? The cubed root of 5 to the third, what would that look like? What would I put? What happens to these 3s? Like what? Cubed root of 5 cubed. What's the answer?
Would it just be 5?
Sure would. I was like, those 2 just cancel out. And then you get rid of the square root sign, you know. Okay, number 3, the cubed root of 64. The cubed root of 64.
4.
4. Awesome. Okay, be careful with this one. Read, you can do number 4 for me. That would be great. Fourth root of 81. What times what times what times what makes a positive 81?
Three.
So positive 3 times positive 3 times positive 3 times positive 3. Also, negative 3 times negative 3 times negative 3 times negative 3. So that's why I put plus or minus 3. All possible roots for the radicals below. So square root of 16 means that I could have a couple choices. I do have a couple choices. So what am I going to put? When people's hands are up, and I cannot see them. Oh, Naomi, I'm sorry.
Sorry, that was from over. Sorry.
Okay, well, all right, guys, the square root of 16. Read again. I need new people too. I mean, Read, you're great and all, but I need more people.
4.
Okay, good, but I'm gonna put plus or minus 4. Okay? Because negative 4 times negative 4 is a 16. All right? How about the square root of 121? I'll do it. Plus or minus 11. Oh, good. Logan and Naomi. So 289, Logan, 289. Any thoughts on that?
Is it plus or minus 17?
Yep, it is. When I have a fraction, 4 over 25. 4 is a perfect square and 25 is a perfect square. So since they're both perfect squares, I just take them out. It's going to be plus or minus. And I'm going to do square root of 4, 2. Square root of 25, 5. Plus or minus 2/5. Cube root of 8. Naomi, go ahead.
2.
2. I cannot do plus or minus on this one because a negative 2 times negative 2 times negative 2 would be negative 8. And I don't want negative 8. I just want positive 8. Okay, 343. Ooh, it is something. I wrote it down here. Huzaifa.
7.
7. And it's odd, so I cannot include the negative. It's not negative 7 ever. It's just 7 times 7 times 7. Okay, the cubed root of negative 125. Something times something times something. Nathan.
-5.
Good, -5. Good. Okay. Ooh. Naomi, you're good. Give me some other people, unless I'm missing some people. Vinay, go ahead. The cube root of negative 1 over 27. Something times something times something makes negative 127.
Is it -1 over 3?
It is. Good job. -1/3. Okay. Fourth root of 1. What times what times what times what makes 1? Dimitri.
1.
Yeah. Easiest question of the day. Okay, this is a comma. I apologize for the typo. Please, 2000. I messed up. My mistake. And really and truly, we don't usually put commas under there, but yeah. Sean.
Plus or minus 7.
It is plus or minus 7. The reason I knew it was plus or minus is because it had an even root. I'm going to talk about that down here. -7 times -7 times -7 times -7 Okay. All right, 4,096. 4,096. Now we need new people. I don't think this is one you've actually have memorized. I'll do it. I'll do it. Plus or minus 8. Who memorizes 4,096? Like 81 over 16. They're both fourth roots. 81 over 16. Vinay?
Is it plus or minus 3 over 2?
It sure is. The plus or minus is because I have an even root, and I can do a negative an even amount of times and get a positive answer, right?
Mhm.
So here we go. If it's even with a positive root, I used a highlighter last time. I'm going to do that this time too. Okay, check this out. If the number underneath is positive, but this is an even number, it's going to be a real root, like a whole number, a real number. And there's going to be 2 of them. And it's going to be a plus and a minus. Okay. Odd. If I have a positive number underneath, but it's like a third root or something, then that's going to be also real. There's going to be 1 root, and it's only going to be positive. If I have a negative number underneath the root, that would be like the cubed root of negative 125 up above. It's going to be real, but there's only going to be 1 answer, and it's going to be negative. Oh, I saw somebody have their hand up. Vinay, you helped a few times, so you're good.
Okay.
If I have an even number, like a square root of like negative 9, that would involve my I. Remember my I, my imaginary number? I have 2, and it'd be a plus or a minus. Okay. Some textbooks don't use the plus or minus sign. They use an absolute value instead. So you need to know that that exists. I also want to let you know, again, the square root of x squared is just x. The cubed root of any number, like 8, whatever, to the third, equals that number, 8. So the 2's like cancel each other out, and the number no longer has a radicand. I'm sorry, a radical symbol. The radicand is the number underneath. All right, I'm going to turn the page. All right, I'm starting to talk about fractions now. They're called rational exponents. And it's going to be something like 5 to the 2/3. Okay. Sorry, 5 to the 2/3. The denominator goes down and becomes the root. The denominator goes down and becomes a root. The top number sticks with my base. My base is 5, my exponent is now 2. The numerator stays with the base, stays with the big number. The denominator down into the root, or maybe you can see this way, whatever's the right way for your screen. Okay. So 25 to the 1/2. There, you can see. The 2 goes in front. Square root of 25 to the first power. But honestly, nobody does. Nobody does to first power. Nobody even writes the 2. Anyways, the square root of 25. The answer is 5. Plus or minus 5. I'm sorry. Okay, let's be very careful on number 6. Number 6 is tricky. Pay attention, please. Stay with me. The 5 goes to the front. The 5th root of, and I'm going to put it in parentheses, and I'm going to show you why. Because I have to do 32 squared. 32 twice. But I'm not going to get a calculator and go 32 times 32. No, 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 no. The reason that I chose 32 as your base is because 32 has a 5th power. What times what times what times what times what makes 32? 5 times. What is that number?
2.
2. So now I'm going to rewrite it. Thank you. The 5th root. And instead of 32, I'm going to write 2 to the 5th. And I have to, that's 32, right? But didn't I have 32 squared? I had to do 32 2 times. So then I'm going to go 32, 2 to the 5th, times 2 to the 5th, which is also 32. The 5th root of 2 to the 5th times 2 to the 5th. Okay. The 5th root of 2 to the 5th. I did this on the front. Remember? Right here, down below. It's just the number, the base, that base number. So I'm going to come and take this out and put a 2. The 5th root of 2 to the 5th, this first one comes out as just a 2. The multiplication stays, and the second one comes out as just a 2. The 5th root of 2 to the 5th, 2. The 5th root of this 2 to the 5th, 2. 2 times 2 equals 4. Okay.
Wait, so you brought the 2's down
Because this 5th root and the power of 5 were opposites of each other and they canceled each other out. Whenever those numbers are the same, the answer is that number. Like what is the square root of 7 squared? What would you say the square root of 49 is? What's the square root of 7 squared? I'm asking you.
7.
So the 2's cancel each other out and the number comes out alone without a square root. Comes out alone. Let's do number 7. The denominator 5 comes to the front. The 5th root of 5 squared. Well, this little 5 and this little 2 aren't going to do anything. This is a nothing problem. Nothing, boring. Number 8, however, I can do something with. The 3 comes to the front. The cubed root of 27 squared. So I'm going to have to write 27 2 times, right? But does 27 have a third power, like a third root? Does 27 have a third root? So like someone?
3.
Yep. 3 to the 3rd power. And how ironic that there's a 3 in my root. How funny. Ha ha. No, it's not. I did it on purpose. 3 to the 3rd. That's 27. But I said twice. 27 squared. So do it again. Awesome. But look at all these threes. Don't get confused. There's a lot of threes. The cubed root of 3 cubed. These threes right here. Gone. Out comes a 3. The cubed root of this third. Out comes a 3. 3 times 3 equals 9. Okay. Rewrite in rational notation. Guess what rational notation means? A fraction, exponent. So imagine that you're like going backwards from what all those little like circular arrows I did. This 4 now comes and goes underneath. This 8 comes and goes underneath. 2 to the, what's the numerator? What's the denominator? Someone knew. Like I know that a lot of people are trying to be sneaky and answer like over and over again. Because now I know your voices. What's my fraction right here? 2 to 2 to the what?
3/4.
Mm-hmm. Three to the, what's my numerator? What's my denominator?
11/8.
Mm-hmm. Excellent. Okay, last 2 problems we're gonna do. I am now giving you problems where I'm like totally making you like think backwards 3 steps.
For 10, do you need to simplify it?
No, they don't have a common factor. I can't. Okay. Check this out. Number 11, look at it. 32 to the 3/5 equals 32 to the 1/5 times 3. So it's like, isn't it true that 1/5 times a 3 equals 3/5? So I'm basically taking the numerator out. Look at this 3. I decided that I would do 32 to the 1/5 to the 3rd because 1/5 times 3, I would multiply those if I needed to. 1/5 times 3 is 3/5. So I worked backwards and I started with whatever the numerator was and I pulled that out and made it on the outside of the parentheses. The reason you do that is because 32 to the 1/5 is look. What's the 5th root of 32? In that parentheses, what number could I put instead of 32 to the 1/5 or the 5th root of 32? There's like an easier number. 5th root of 32. Something.
2.
2. So isn't that crazy how I started with this base and the exponent was a fraction called a rational notation. I then rearranged it so that I could break down the 32 and it became 2 to the 3rd. 2 times 2 times 2 is 8. Insane, you guys. I love it. Okay. 27 to the negative 2/3. 27 to the 1/3 times negative 2. So I pulled out the negative 2 from the numerator because guess what? There's a 3rd root of 27. Someone new, the third root of 27.
3.
3.
Excellent job. 3 to the negative second. Do you recall negative exponents back from algebra 1? It's not negative 9. Don't be that kid. It says negative 9. What does a negative 2 do?
1/3 square.
Yeah. The negative exponent drops it down into a fraction. It becomes 1/9. Okay. So we're going to stop there. We're good. Your homework is the next page, 1 through 18.